This is the solution for question 5 of homework 2. The scenario is given that the customer flow at a grocery store follows a Poisson process where the P of t comma t, the distribution is given. Here t is the time duration and k is the number of arrivals. In the question we also given that the probability that at least one customer arrives in the first 2 minutes is 0.3. We are asked to find the parameter lambda. So let us denote event E as at least one customer arriving in 2 minutes. E0 be the event when no customer arrives in the first 2 minutes. So P of E is 1 minus P of E0. Now E0 is straightforward because no customer arriving means k equal to 0 and the time duration is t equal to t. So substituting those values, we get the lambda value after simplifying as 0.178. So we're doing this because in the question we don't know how, since it's given at least one customer arriving to be point t, can be 1, 2, so on up to infinity. So we do 1 minus probability of no one arriving. Now moving on, in the next part we are asked to find the probability that in the first 3 minutes no customer arrives. So this is straightforward. Let us denote E1 as event when no customer comes in 3 minutes. So here the duration is 3 minutes and number of arrivals is 0. Therefore putting t equal to 3 and k equal to 0 in P of t comma k and simplifying, we get the value P of E1 equal to 0.58. So this is the probability that no customer arrives in the first 3 minutes. Now next part is I have to find the probability that in 10 minutes at least 2 customers will arrive. So let E2, denoting E2 as the event where at least 2 customers will arrive. So P of E2 is 1 minus a probability of no customers arriving plus 1 customer arriving. So similar to the first part, since it's given at least 2 customers, we have to assume 2, 3, so on up to infinity. Therefore the probability is 1 minus P of t equal to 10 comma k equal to 0 plus P of t equal to 10 comma k equal to 1. So k equal to 0 is for no customers and k equal to 1 is for one customer. Here the duration is 10 minutes, therefore t equal to 10. Substituting the values, we get the final result P of E2 equal to 0.53. So in the final part of the question, we are asked to find the probability that in 1 minute exactly one customer will arrive. So let us denote it by E3. So P of E3 is just P of t equal to 1 and k equal to 1. Since exactly one customer arriving is k equal to 1 and the duration is 1 minute, which is simply e power minus lambda into lambda. Substituting value of lambda and simplifying, we get the final result. So this question, we can extend this discussion to many different types of scenarios, similar like the number of trains arriving at a station. Let us say the number of trains arriving at a station is also a Poisson process. We can be asked the probability of getting a train in the first 10 minutes exactly, and so on. And also a more complicated question would be 2 different trains arriving at a station which are independent, and finding the probability that in the 1 minute we will get at least one train.